कंटिन्यू करेंगे MCS 208 का इम्पोर्टेंट क्वेश्चन मीन्स ये 5 ईयर नहीं, मतलब 5 क्वेश्चन सेट है। लाइक जैसे 2020 जून 2025 का है और दिसंबर अभी हम लोगों का होने वाला है, ठीक है। वैसे 2024 का दोनों सेशन, जून और दिसंबर वाला 2023 का, तो टोटल 5 सेट है मेरे पास, ठीक है। वही सारा क्वेश्चंस हैं जो कि रिपीट भी होते हैं, तो उसके अकॉर्डिंग हम यहाँ पे आंसर के साथ रखे हैं। इसको क्विक रिवीजन कर लेते हैं एक बार, ठीक है। ओके, पहला है व्हाट इज एन एरे, राइट एन एल्गोरिथम फॉर एडिशन ऑफ 2 मैट्रिसेस विच टेक्स 10 मार्क्स। An array is a collection of elements of the same data type stored at contiguous memory location. Each element can be accessed using index number. करेक्ट है, लिखने का सिंटेक्स ये ऐसा रहेगा। Represent each element. Array are useful when we want to store multiple values under one name instead of many variables. एग्जाम्पल है लाइक एक ट्रे का एग्जाम्पल है। ट्रे जो है कह रहे हैं उसमें एक एक स्लॉट रहता है, उसमें एलिमेंट रहते हैं और जो पोजीशन ऑफ स्लॉट है वो एक इंडेक्स है। मैट्रिक्स एंड इट्स एडिशन 2D फर्स्ट एंड सेकंड, ठीक है। 2D एरे का ये A and B, 2 matrices A and B can be added only if they have same number of rows and columns, ठीक है। सेम नंबर ऑफ रोज एंड सेम नंबर ऑफ कॉलम, करेक्ट है। एडिशन बोला है। Algorithm add matrices A, B, C, M and N. Start read matrices A and B order of M into N. Okay, real life example to remember. Sales into matrix addition, like combining data from similar tables. Product week 1 week 2 A and B, ऐसा हो जाएगा। सेम रोज एंड कॉलम है। टोटल इक्वल टू week 1 plus week 2, 10 into 15, 10 plus 5, 30। इसको स्किप करो। Arrays are like array, same type, fixed size. Matrix addition equal to combining 2 similar types row by row, column by column. Formula is this. Describe the implementation of queue using linked list. Queue is a linear data structure that follows the rule FIFO. फर्स्ट इन फर्स्ट आउट। क्यू में जैसे बैंक क्यू हो गया, टिकट काउंटर का क्यू में खड़े होते हैं, जो फर्स्ट में रहता है फर्स्ट में आउट होता है, उसको मिल जाता है तो वहाँ से आउट होता है। फर्स्ट इन फर्स्ट आउट मीन्स फर्स्ट एलिमेंट इंसर्टेड इज द फर्स्ट वन रिमूव्ड, लाइक अ लाइन टिकट at a ticket counter. When people stand in a queue, the person who enters first gets the ticket first front and the last person waits जो है rear, इसको rear बोलेंगे। What is a linked list? हाँ, a linked list is a collection of nodes where each nodes contain linked list is a collection of node when each linked node and pointer value stored in the node address is the next node. Okay, queue using linked list. We use a linked list to represent a queue. We use a linked list to represent a queue. Queue using linked list. We use linked list to represent a queue. It can grow and shrink dynamically. No memory waste in the array. The front pointer points to the first element, or rear pointer points to the last element. Correct? Think of pointer queue. You send multiple print jobs. Each one joins the rear. The printer always print the front first job first. That's a real world linked list queue. Structure of a node in a C syntax. Struct node data node and pointer next. Okay, data and pointer, ठीक है। Then we maintain 2 pointers, struct node front and gear equal to operation on queue using queue nq or dq insert sorry, in queue and dq operation of queue linked list में in queue और dq insert a rear, ठीक है। और dq delete from front। algorithm for nq कुछ है, okay। if the queue is empty, इसका यहाँ पे if the queue is empty both front and rear points to the new node। algorithm of DQ. If Q is empty, both front and rear points to the new node, otherwise attached to the new node. और DQ में है the first element is removed. If the first element is removed, the queue becomes empty. Both points to the null. Advantages: no size limitation, efficient memory uses, easy insert deletion from and singly. Slightly disadvantages: slightly more complex to implement than array, use extra memory for pointer space. Real life example to remember it: each coach is node. Link in the next. Passenger enter from the rear, है ना, and they leave from the front. DQ. In queue enter from the rear and leave from the DQ. Okay. Diagram: front data next, data next, data null and rear. rear से enter करेगा, front से next में जाएगा. Line of people: link list train of connected coaches. Front exit gate, rear entry gate. Write a non-recursive algorithm of post-order traversal of a binary tree. Explain with example. Okay, so what's a binary tree? A binary tree is a hierarchical data structure where each node has almost two children. Okay, binary 0 और 1 ऐसे याद करने का. And binary is the hierarchical data structure. ठीक है, data structure पढ़ रहे हैं. Binary tree is the hierarchical data structure where each node has two children. Okay, where each node has two children, left child and right child. Example A. What is post order traversal? Post, okay. Traversal means visiting all the nodes of the tree in a specific order. In order, pre-order, post-order. Traversal means visiting all the nodes of the tree in a specific order. There are three main types. In order, left, right, बीच में root. In order, pre, root. Okay. इसको याद ऐसे करने का. इन ऑर्डर, लेफ्ट राइट बीच में नोड है. ठीक है. प्री, ठीक है. क्या होगा, लास्ट वाला ऐसे रहेगा, पहला वाला ये हो जाएगा, शिफ्ट हो जाएगा. ठीक है. ओके. पोस्ट में अगेन लेफ्ट आ जाएगा इधर और राइट ये उधर चला जाएगा. लेफ्ट राइट. पोस्ट में लेफ्ट राइट, प्री में ओके. पोस्ट वी विजिट पोस्ट. ओके. लेफ्ट सब ट्री, right subtree and root is the last one. Okay, so I see that. So post order, ठीक है, left right, D E B पोस्ट ना, लेफ्ट राइट रूट, D E B. ठीक है. B में गए, D E B, B में गए. ठीक है. फिर यहाँ पे गए F से ऊपर जाएगा C, C से ऊपर गया A. Why non-recursive? Normally recursion is used to handle tree traversal automatically. Normally recursion is used to handle tree traversal automatically using call step. But a non-recursive approach, we manually use a stack data structure tracks. Stack works only for last in first out. Stacks में सिर्फ पार्टीज में प्लेट्स रहते हैं. ठीक है. तो लास्ट में रहेंगे उसको पहले आउट करते हैं. लास्ट प्लेट, स्टैक ऑफ प्लेट्स को हम लोग पहले पिक करते हैं. वही बोल रहा है कि लास्ट इन फर्स्ट आउट. Perfect for reversing the order of the tree processing. Algorithm non-recursive using the two step. Okay, we will use two stack as well as S2. Root, create a two empty stack as well as S2. Push root into S1 while S1 is not empty. Repeat pop an element from S1. Okay. एल्गोरिदम को हम बाद में देखेंगे अच्छे से समझ के. इसी को देखो, समझते हैं। कंसिडर द सेम ट्री, ये जो है एल्गोरिथम नॉन रिकर्सिव पोस्ट ऑर्डर ट्रेवल्सन यूजिंग पोस्ट ऑर्डर, ठीक है, मतलब लेफ्ट राइट एंड रूट। ऐसा है ट्री मेरा, पुश रूट ए इंटू S1, S1 में ए क्या, पॉप ए, पुश टू S2, पुश बी एंड सी इंटू S1, ए गया, ठीक है, बी और सी को दे दिए, ठीक है, पॉप सी, अगर सी निकाले, एफ को किया। एल्गोरिथम को बाद में देखते हैं, डेफिनेशन देख लेते हैं, ठीक है, समझने में टाइम लग रहा है। रियल लाइफ एग्जांपल टू रिमेंबर इजीली, फर्स्ट यू क्लीन ओके ट्री shaped candelier, and first you clean the left side, then the right side, and finally the corner. The post left right root, the stack acts like to-do list reminding. Diagram draw in a hall. Post order left right and root. D E root, ठीक है, F C A. Advantages of non-recursive method: avoids recursive method, useful in the system where recursion isn't supported, efficient for large trees memory, post LR, non-recursive two stack, real life chaining, clean left right and center. Okay, explain what is collision in the context of hashing, what method can be used to employ address collision. Okay, what is hashing? Hashing is a technique used to store and retrieve data quickly using a hash function that maps data to the specific location into a hash table. क्या क्या समझना है, देखो हैशिंग का मतलब टेक्निक है स्टोर एंड रिट्राइव डेटा, ठीक है, स्टोर एंड रिट्राइव डेटा, hash function, using a hash function that maps the data to a specific location in a hash table. Hashing is a technique used to store and retrieve data quickly using a hash function that maps data called a key specific location called a hash address in the hash table. Correct. We have 10 lockers. Use the hash x key है to hash 25, ठीक है, 5. What is collision? A collision occurs when two or more keys generate the same hash. Collage हो जाता है. A collision occurs when two or more keys generate the same hash addresses using a hash function. Same, like two or more keys generate the same hash address using a hash function. In simple words, different keys, same location in the hash table. And these are the like keys 25 and 25 produce the same hash address, and this way the collision happens. Imagine you have 10 lockers, number 0 to 9. The two students, says Neha and Ravi, both get assigned to locker 5. By mistake, they can keep their belongings in the same locker. That's a collision. So you need a method to resolve it, just like assigning one student another nearby locker. Okay, why collision happens? Hash table is similar than the range of possible keys. Hash table is smaller. Hash table is smaller than the range of collision keys, and hash function isn't distributing keys uniformly. Too many elements inserted, table is full or nearly full. Method to handle collision. There are two main approaches. Open addressing methods. Okay. Method to handle collision. Open addressing method. In this method, when a collision occurs, the algorithm search for the another empty slot in the hash table. अगर जब भी collision आता है तो algorithm searches for the another empty slot in the hash table itself. Linear profiling. If the slot is occupied, move sequentially to the next available slot. हो गया. Advantages: simple to implement, causes primary clustering. In real life example, parking car in a row. If your spot is taken, you try the next one. Quadratic probing. Instead of moving one by one, jump by position. Double hashing. Quadratic probing. Linear probing का मतलब देख लेते हैं. Slot is occupied, move sequentially to the next available slot. Simple to implement, cause primary clustering. हो गया. Parking car in a row. if your spot is taken, you try to the next one. Okay, so linear programming ये है. क्या example? Parking car in a row. Parking car in a row. If your slot is taken, you'll try for the next one. This is where if slot is occupied, you move sequentially to the next available slot. Correct. Quadratic probing. Instead of moving one by one, jump to a square position means. Okay, reduce clustering may skip over this. In parking, instead of checking the next stop, you check the first, fourth, ninth position. Instead of checking to the next, you change करेंगे हम लोग. Double hashing uses two hash function to find a new slot. In your park, if your first parking is parking slot is full, go to the another lot based on the second rule. Okay, through hash function find a new slot. Separate chaining, closed addressing. Each slot in the hash table contain a linked list or chain in multiple key to same slot. They are linked together in the list. So advantages easy and simple to implement. Even work even when the table is more than full. Disadvantages: use extra memory for linked list, like keeping multiple letters in the same mailbox, chaining one after another. Comparison, like linear clustering, primary, extra space, no sequential slots, quadratic jump pattern, double hashing, two hash rule, separate chaining, multiple letter as a per slot. So real life memory tape for this: collision, two people assigned same locker. So when two people assigned to the same locker, that time the collision happens. Okay, linear probing, checking next locker. Quadratic probing का मतलब jump to the few locker ahead, like few locker ahead आगे. Double hashing, moving to the another building. And separate chaining, sharing same locker, linked list. Okay, memory, like I'm giving you the quick memory trick to remember it for like long. Hashing, assigning locker number, collision, two people same, like hashing, assigning locker numbers, and collision, two people say same locker. Solution: try next. Linear, skip ahead. Quadratic, second rule, double, share local chaining, locker chaining हो गया. Okay, this is the important one. Okay, what is DFS and how does it differ from the BFS? Give the example. Okay, what is graph traversal? Graph traversal mean visiting all the vertex nodes and the graph exactly once in a particular order. So graph traversal mean visiting all the vertex nodes of a graph exactly one in a particular order. There's two main way to traverse a graph, like DFS and BFS. Depth first searching, which is DFS definition. DFS first search is a graph traversal algorithm that explores a node deepest path before backtracking. In simple, go as deep as possible, then backtrack and explore other branches. There's the algorithm. Data structure, use the stack LIFO. Okay, DFS use the stack LIFO. Real life example, think of an exploring a maze. You always move forward as deep as possible down to the one path. If you reach a dead end, you backtrack and try a new path. This is DFS, deep exploring first. ठीक है, DFS starting from A, go to B, go to D, no neighbor. Okay, backtrack, go to where? D. Okay, C, then go to E, A B D. A हो चुका है, A B D, then यहाँ से C and D. Okay, breadth first starting, breadth first search is a graph traversal algorithm that explore all neighbor at the node first before moving to the next. In short term, go level by level. Okay, explore all nodes at one step before moving deeper. That's the algorithm. Real life example, think of spreading news in a classroom. You tell immediate neighbor, like first level, then they tell their neighbor. There's this way the news spread level by level. That's called BFS. Okay, याद करने के लिए BFF क्या करते हैं? दे शेयर न्यूज़ फर्स्ट लेवल सेकंड लेवल करके ना. BFS शेयर एक नेबर से याद रखना, जिससे कि पता रहेगा. BFS जब भी पूछेगा ब्रेथ फर्स्ट क्या है, ब्रेथ फर्स्ट सर्च. ओके हाँ, तो ये नेबर बाय नेबर बोलता है, ठीक है। जैसे कि देख लेते हैं, स्टार्टिंग फ्रॉम द ए, ठीक है, विजिट ए एंड बी क्योंकि नेबर है, ओके। देन डी में आता है, डी का नेबर नेबर ऑफ बी, ठीक है। फिर ई में जाता है, ई से वापस सी में जाएगा, यानी कि ए आएगा, बी और सी, ए बी और सी, ठीक है, बी और सी खत्म, फिर डी आएगा, डी का तो कोई है नहीं, फिर इसका बाद इधर जाएगा, ए बी एंड सी, सी से फिर डी और ई, हाँ करेक्ट है। डिफरेंस बिटवीन डी एफ एस एंड बी एफ एस, डेप्थ फर्स्ट, डेप्थ में जाते रहेगा, नीचे आते रहेगा, ठीक है। वी एफ एस ब्रेथ फर्स्ट है, गोज डीप बिफोर बैक ट्रैकिंग एंड एक्सप्लोर लेवल बाय लेवल, और ये स्टैक लीफो का यूज करता है, ये क्यू का ना, बी क्यू एंड डी एस, ऑर्डर डेप्थ फर्स्ट, ब्रेथ फर्स्ट, लेस चिन्स स्टैक more यूज करता है, मेमोरी यूजेस पाथ फाउंड नॉट ऑलवेज द शॉर्टेस्ट पाथ, ऑलवेज फाइंड द शॉर्टेस्ट पाथ, एग्जांपल ए बी सी डी, ए बी सी डी ई, ओके। Exploring a cave, go deep until that end, then backtrack, and DFS spread news, reach everyone level by level, ठीक है। For memory trick, DFS deep first, stack, math exploration, DFS board first, queues and web spreading. What is time complexity? How does it differ from space complexity? Give an example for each. So, what is the time complexity? Definition. Time complexity is an algorithm, is the amount of time it takes to run as function of the input size. Input size n. Time complexity of an algorithm is the amount of time it takes to run as a function of the input size के according. In simple words, it tells how fast an algorithm runs when input grows larger. It tells how fast an algorithm runs, okay. Time complexity. Real example for this, imagine you are searching for a name in your phone contact. If you check one by one, it takes more time, okay. Imagine you are searching for a name in your phone contact. For checking one by one, it takes more time, linear search, and contacts are stored as a binary search. If contacts are stored and you use binary search, it must faster. Okay, so binary search has lower time complexity than linear search. समझ में आया ना? If you check one by one, it takes more time, है ना, linear search हो गया. If contact are stored and you use binary search, it is much faster, ठीक है. Of one of and of log time complexity. Accessing an array. Okay, accessing an array, constant time. Linear search, time increases linearly with input. Binary search, time grows slowly as the input doubles. Bubble sort, nested loop, bubble, nested loop. कुछ कीवर्ड्स, कुछ की पॉइंट्स विच मेक्स यू रिमेंबर फॉर मेमोरी ट्रिक के रूप में आप इसको यूज कर सकते हैं, जैसे बबल्स. यू कैन सी द बबल्स ऑल्सो. द थिंग इज एज अ नेस्टेड लूप्स, ओके. Recursive and very slow. What is time complexity? So space, time complexity I have done. Space complexity of an algorithm is the amount of memory required to solve a problem, including input space, temporary space, output space. It measures how much memory an algorithm uses while running. Real life example. One second, please. Real life. If you store 100 students' name in a memory, it uses some spaces. If your algorithm also uses temporary variables on array, it needs extra space, and that's space complexity. If you store 100 students' name in the memory, it uses some space. In your algorithm also uses temporary variables or array, it needs extra space. That's space complexity. Difference between time and space complexity, meaning measure time taking by algorithm and measures memory used by algorithm. Depends on number of operation, variable, data structure used. Goal: minimize execution time, minimize memory uses. Measure in B of time, 0 the O O of time and B of space. Binary search of this and of an example to calculate for I कि मैं रिटर्न आई लीनियर सर्च, ठीक है। यहाँ पे एक लूप बना है फॉर आई इज इक्वल टू 0, आई इज लेस देन एन, ठीक है। एन जो इनपुट लेंगे उसका अकॉर्डिंग में बढ़ेगा एन प्लस प्लस, ठीक है। एन 0 एरे के में उतना साइज उसमें चला जाए, मतलब 0 पड़ेगा तो एड इक्वल टू रहा तो रिटर्न आई कर देगा। Time complexity, loop runs ends time in worst case 0, then it uses a few variables, time 1 space 1. Binary search. Real life analogy, time complexity, time you take to find a book in a self space, हाँ concepts देखो, time complexity, time you take to find a book in a self space, space cells need to store all books, okay. If you organize book alphabetical, better algorithm, you search it faster, less time complexity. But if you use multiple boxes, space complexity increases. Quick memory trick, time speed, how fast it runs, space memory. Time complexity, how long it takes, space complexity, how much memory it will use. Linear search, time 0, space 0, and binary linear search. Time equal to speed, how fast is one, space equal to memory. Time complexity, how long it takes, space, how much memory it will take. So, okay, next. Stack implementation using an array. What are the advantages and limitations of this approach? Illustrate with example. Okay. What is stack? Stack is a linear data structure that follows the rule LIFO, last in first out. That means the element inserted last is removed first. Real life example, stack of plates. Yes, you add new plates on the top, you remove the top plate first. That's how stack works. Stack operations like push and pop. There are two main operations: insert an element on the top, remove one from the top. Okay. Other helpful operation: peek top, view the top element without removing it. Peek top, view the top element without removing it. Is empty, check if the stack is empty. Is full, check if the stack is full. These are some operation of stack. Peek, just view, only for view. Is empty is checks if the stack is empty or not, and is full is check if the stack is full or not. Implementation of stacks using array. In this method we use an array to store element of the stack. In this method we use array. In this method we used an array to store element of the stack. We also maintain a variable called top that points to the current top element. Okay, top equal to algorithm, top equal to -1. It means the stack is like empty. Push means inserted. If top is equal to max -1, print stack overflow. ठीक है. And stop, else top equal to top plus 1. अगर नहीं तो इसे 1 कर देगा. stack top is equal to item if and pop algorithm if top is equal to -1. ठीक है, अगर ये ऐसा हुआ, ठीक है, यानी तो stack underflow, ठीक है, empty है, ठीक है. इसका मतलब अगर empty है तो underflow stop, else इसमें ऐड करेगा. Peek operation, if traversible stack empty, peek मतलब top, just for checking the view the element without removing it. Push 10 हो जाएगा 1 में. Again if push 20 then 20 हो जाएगा यहाँ पर, स्टैक ऊपर फर्स्ट में आ जाएगा। हाँ, फिर 30 करेंगे, 30 बस पॉप करेंगे तो स्टार्टिंग इधर से निकाल दिया हो, टॉप से ही निकाल दिया। एंड पिक करेंगे, सो पॉप करेंगे तो देखो real life, and think of a browser back button. Every time you visit a new page it puts on the top of your stack. When you press back, it will took you to the current page is popped, you return to the previous one. Okay, advantages of stack. Okay, 1 second. Advantages of stack using array. Simple to code and understand, easy implementation, fast access, all operation, push, pop, peek. Okay, memory efficient, fixed size, memory is allocated once, no dynamic allocated over. ठीक है, array के लिए तो like fixed रहता है size. Used in recursion expression evaluate. Stacks are used initially for function calls and evaluating arithmetic expression. Limitation of stack using array. Fixed size, static. Once declared, the stack size cannot grow, leads to overflow if more elements are pushed. Waste memory. If the stack is only partly filled, unused array space is wasted. No flexibility, cannot shrink or expand dynamically. Okay. टॉप में चला जाएगा. Plate tray. Push, add a new plate on the top. Pop, remove from the top. Peek, see the top plate without removing it. A stack implemented using array uses a fixed size structure to store element in leaf order. It is fast and simple but has a fixed size limitation. Okay. For a singly linked list, write an algorithm to count the number of the items stored in it. What is singly linked list? A singly linked list is a linear data structure in which elements stored in node, data field and pointer. Okay, single linked list is a linear data structure in which elements are stored in nodes, and each node contains data field, the actual information, the pointer address to the next node. Okay, last node points to the null, meaning the end of the list. Okay, real life example for it. Imagine a chain of paper. Each clip is connected to the next one. Using the link, you can count how many clips are there by starting from the first and following each link by one, just like counting nodes in a linked list. Again, imagine a chain of paper clips. Each clip is connected to the next one using a link. Okay, each clip is connected to the next one using a link. You can count how many clips are there by starting from the first and following each link one by one, just like counting nodes in a linked list. Okay, now purpose of the algorithm. We need to count how many nodes are there in the list by traversing the entire list from the head node till we reach null. ये पर्पस ऑफ एल्गोरिदम का है, ठीक है। ओके, एल्गोरिदम काउंट नोड्स इन अ सिंगल लिंक लिस्ट ये। ओके, आई एम मूविंग टू द नेक्स्ट एग्जांपल. लेट्स से आवर linked list is think of counting people in a queue. You start from the first person, move to the next, and keep increasing your count until the end of the line. That's exactly how the nodes is linked list work diagram. Because each node is visited exactly once, space complexity uses only one extra variable. Advantages of algorithm: simple and efficient, works for any length of linked list, need only one traversal, no space required. In a singly linked list, each node in a singly linked list, each node contains data and pointer to the next node. To count the number of items traversed from the head node till null, incrementing order, time complexity, space complexity. इसको अगर हम यहाँ पे एक बार पढ़ते हैं, ओके, इसका डेफिनेशन देख लेते हैं. Singly linked list is a linear data structure in which elements are stored in nodes and each nodes contain data field, the actual information like number and name, pointer, address to the next node. Imagine a chain of a paper. Each clip is connected to the next one using a link, and you can count how many clips are there by starting from the first and following each link one by one, just like counting the nodes. Purpose: we need to count how many nodes are there in the list. Correct. Next है Kruskal algorithm for finding minimum cost spanning tree in the graph with the help of example. Okay, what is spanning tree? A spanning tree of a connected graph is a subset of edge. Spanning tree of a connected graph is a subset of edge that connects all the vertices together without forming any circle and uses the minimum possible number of edges. समझ नहीं आया? No worry, I will continue same thing again. A spinning tree of a connected graph is a subset of edges that connected all the vertices together without forming any cycle and uses the minimum possible number of edges. If a graph has v vertices and spinning tree has v minus 1 edges, what is the minimum cost spanning? MST. Among all possible spanning trees, the MST is the one with the minimum total edge v. It helps in minimizing network cost like laying telephone cables, designing roads, or computer networks with minimal total length. A spanning tree is a connected graph is a subset of edge that connects to the vertex together without forming any circle and uses the minimum possible number of edges. If a graph has v vertex and spanning tree has a v minus 1 edges, what is MST? Among all possible spanning trees, the MST is the one with the minimum total edge weight or cost. It helps in minimizing network cost like laying telephone tables, designing roads and computer networks with a minimum total length. Real life example: imagine connected 4 cities with telephone wires. Each wire has a cost. You want all connected in a lowest cost. That's imagine you connected 4 cities with telephone wire. Each wire has a cost. You want all city connected but the lowest total cost. That is what Kruskal's algorithm helps. Kruskal algorithm. Kruskal's algorithm is the greedy algorithm that finds the minimum cost spanning MST by selecting edge increasing order in their weight, ensuring no cycle is formed. Again, among all the possible spanning tree, the MST is one of the minimum total edge weight. Spanning tree is a connected graph to subset of edge connected all the vertex together without forming any cycle. Simple and efficient first span graph always give the minimum spanning trees works well when edges are already sorted. Limitation: insufficient for dense graph, needs sorting of edge, first require cycle disjoint sets. Real life analogy: think of a connecting village with roads. You list all roads with their distance. Choose the shortest road each time, but don't from loop. Kruskal. Keep sorting edge frames. Pick from connected vertex. Build MST no cycle. Okay. Short summary of the revision. Kruskal algorithm is a greedy algorithm that builds a minimum cost spanning tree by adding edge and increasing by order, avoiding cycle using union find. Example: MST time complexity. What are the characteristics of avial tree? How do rotation help in balancing avial trees when it becomes unbalanced? What is an avial tree? An avial tree is a type of hmm. What are the characteristics of avial tree? How do rotation help in balancing an avial tree with? What is an avial tree? An avial tree is a type of self-balancing binary tree, BST. It was named after its invention. Okay. In an avial tree, the height of the left and right subtree of every node differ by the most. Okay. Characteristics of an avial tree. How do rotations help in balancing an avial tree when it becomes unbalanced? So avial trees. An avial tree is a type of self-balancing binary search trees. It was named uh, sorry, after its invention Adlins, Welsky and Landis. In an avial tree, the height of the left and right subtree of every node differ at most one. A real life example for that: imagine you are stacking blocks evenly. If one side becomes taller, immediately just rotate to the box of balance both sides, right? If one side becomes taller, you immediately adjust a box to the balance both sides. That's what an avial trees do. It keeps the height of the both sides nearly equal. Characteristics of avial trees. Characteristics description: binary search trees follows the BST rule: left root and right balance high. Is the highest balance factor between left and right subtree is at most 1. Balance BF like high left subtrees and right subtrees. Self-balancing: if any node becomes unbalanced, rotations are perfectly automatically. Efficient operation: searching, insertion and deletion all taking due to the height balance. Minimum height keeps the tree height minimum, preventing performance deletions like squid BSTs. Example of balance factor is something like that. What, like when avial trees become unbalanced? And avial trees become unbalanced when insertion and deletion makes the balance factor any node like +2 or -2. To fix rotation are used. Rotation used in balance and avial trees. Like rotation are the small trees adjust that restore balance while preserving the BST properties. There are 4 types. Left LL rotation condition: when a node it inserted into the left subtree of the left child of condition left rotation. Okay, when a new node is inserted into the left subtree of the left child of an unbalanced node, fixed a single right rotation. After inserting 5 balance plus 2 is 30. Apply right rotation is 30. Okay. Right rotation condition. When a new node is inserted into the right subtree of the right child, fix, perform a single left rotation. Single left rotation. Okay, after inserting one balance. Left, apply left rotation. Right, LR, right, left, right. When a node is inserted into the right subtree of the left child, लेफ्ट रोटेशन ऑन द लेफ्ट चाइल्ड देन राइट रोटेशन ऑन द राइट चाइल्ड. ठीक है, इसको अच्छे से एक और बार पढ़ना पड़ेगा. एग्जाम से पहले हम एक बार और पढ़ेंगे. अभी जस्ट काइंड ऑफ अंडरस्टैंडिंग ले रहे हैं. ओके, condition when a new node is inserted into the left subtree of the right child, perform right rotation on the right child. कुछ है. After rotation balance tree, after performing the appropriate rotation, the balance factor the nodes become 1 2. रियल लाइफ एनालॉजी से समझ में आएगा भाई, नहीं तो नहीं आने वाला ये तो. Think of a varying balance scale. When one side goes down too much, you shift some weight to make it even again. If one side goes down too much, you shift some weight to make it even again. The same way an avial trees perform rotation to stay balanced. Time complexity, search, oath, unflock, and insertion, deletion, rotation. LR, left or right rotation, right rotation. Okay. Case LL, left of left, right rotation, right of right, left rotation, right or left, left plus right, right of right, right plus left. Trips to remember. Same side LNRR, single rotation operation. Opposite like same LRRR, single rotation. Okay, opposite side LRRL, double rotation. Right, left, left plus right, correct. And avial tree is a self-balancing BST where the every node self-balancing BST every node. क्विक सॉर्ट, ये कुछ है. Give an array, quick sort can 10 5 7 6, quick sort partition इनिशियली. ये एक काइंड ऑफ क्विक सॉर्ट का पूरा सॉल्यूशन है. ठीक है, ये यहाँ से तो नहीं समझ में आएगा, इसको कॉपी में बनाना पड़ेगा तो ही समझ में आएगा. इसको हम स्किप करते हैं. ठीक है, बट राइट अप देख लेते हैं. डेफिनेशन, डिवाइड एंड कॉन्कर, प्राइवेट स्ट्रेटेजी, लास्ट एलिमेंट्स एंड सो दी. एक सेकंड इसको देख लेते हैं. देख ही लेते हैं. गिव एन एरे 10 5. ठीक है, क्विक सॉर्ट ए लेना है, लो एंड हाई विथ लो एंड जीरो. ठीक है, कोई भी एक ले लेते हैं. प्रीवियस सिलेक्शन, लास्ट एलिमेंट ऑफ द करंट सबसे 0 है और छोड़ देते हैं इसको, यहाँ पे नहीं होगा समझना ये वाला. तो इम्पोर्टेंट क्वेश्चन में ये 2025 का जून वाले सेशन का ही है. ठीक है, जून वाले सेशन का क्वेश्चंस पेपर है जो कि देख लिए. इसके बाद नेक्स्ट दिसंबर 24 का देखेंगे.